Hello, friends. Today we'll consider how we can organize large amounts of variables, especially when they hold related information. I've already gone ahead and created a script named census and overridden the base node's definition of the ready function. For our hypothetical scenario in this lesson, we are imagining a census worker who needs to record how many people live in each house on a single road in their town. We can declare a single variable to hold all this information. Let's name it Main Street. And the type of this variable will be an array. An array can hold a list of variables of any of the other types. In this case, the type of the variables we are looking for are integers, representing the number of people who live in each house. We can specify the type of contents of an array using square brackets after the type name array, and putting the type of the contents inside the square brackets. Now this array can only hold integers as its contents. Before we can access the contents of an array, it needs to have a size, the number of variables that are contained inside it. Unlike other variables, arrays are more complex and have their own functions. We can access these functions by following the name of the variable with a period, then the name of the function. In this case, the resize function, which sets the number of addresses inside this array, representing the number of houses on Main Street, which we will say is 6. Our imagined town is a little unusual in that the house numbers on Main Street start at 0. So our census worker starts at the house at 0 Main Street and knocks on the door to ask the resident of the home how many people live in the house. We can store a value in an array starting with its name, then using square brackets to mark the address of the specific integer, in this case, address 0, then using the assignment operator. We can assign an integer to that address. So let's say that the house number 0 on Main Street has 5 people living in it. Moving on to the next house on Main Street, address number 1, someone answers the knock at the door and tells the census worker that there are 2 people living in that house. At the next house, address number 2, the house is under construction and has a for sale sign, which means this house is clearly unoccupied, and our census worker records the number of residents as 0. At number 3 Main Street, nobody answers the door, despite the fact that there is a car in the driveway and signs of occupation. What might we consider the census worker should record as the number of residents? We might think that it could be 0. But how would we differentiate between an unknown number of occupants and an unoccupied house? If we consider that the number of occupants of a house should never be considered a negative number, we could use the number -1 to mean that the number of occupants of the house is an unknown value. And at number 4 Main Street, there is again no answer at the door, but the house also appears to be neglected and likely nobody has lived there for quite some time. We could assume that the number of occupants is 0, maybe use the same -1 value for an unknown number of occupants, or create more negative value codes for different situations, like using -2 to mean probably unoccupied but not confirmed. Address number 5 on Main Street doesn't even have a house, but is just a vacant lot. So again, this could be represented with a 0 or another negative value to encode some sort of meaning. Let's print out the results of the census and see what they look like. We can see our array represented as a comma-separated list of numbers encapsulated in square brackets. This does a decent job of representing the number of people living in each house on Main Street, but what if we wanted to use this data to get a total number of occupants of all the houses on Main Street, or an average? If we calculated the sum of all of these numbers, the unknown numbers being represented as negatives would skew the results. One of the best benefits of using arrays to store related information in this way is how easy it is to loop through it. Using the keyword for, we next write the name of a new variable, one which will represent each individual element inside the array, followed by the keyword in, then the name of the array. Like functions, if statements or while loops, this is followed by a colon and an indented block of code which will be repeated. These lines of code will be repeated once for each of our 6 houses on Main Street, and we can name the variable house, as it will be used to access each individual house inside the loop. Let's say we first want to find the average number of occupants who live in an occupied house. That would mean adding up all the positive numbers, then dividing by the number of occupied houses. So we'll need 3 new variables. One for the total number of occupants, another for the number of occupied houses, both as integers, and a floating point number for the average. For each house in Main Street, we can check if the house is occupied if the number stored in the array at that address, now stored in the house variable, is anything larger than 0. If this is true, then the total number of occupants in occupied houses can be increased by house, and the number of occupied houses incremented by 1. After all 6 houses on Main Street have been checked, the loop breaks, and we have our 2 integer numbers, so we can calculate the average by dividing the total number of occupants by the number of occupied houses. Then print out the results. There are plus occupied houses on Main Street, with an average of plus average occupants plus occupants. But if we run this code, the average is represented as an integer, 3, which we know is not correct, since there are a total of 7 occupants in 2 occupied houses. The average should be 3.5. This happened because we performed a division operation with 2 integers, and the result of the operation will also be an integer, even though we are assigning it to a floating point number variable. Godot also provides a warning against using integers in division operations. To resolve this, we can change our integer variables to floating point numbers in their declarations, or we can change their type locally before performing the division. Much the same way as we changed integers into strings before appending them, we can change an integer into a floating point number before performing a division, changing the result of the division to a floating point number as well. Changing the type of a variable in this way is called casting. We are casting an integer to a float. Now we can see the results we were expecting with an average of 3.5 occupants per occupied house. A benefit of GDScript being a loosely typed language is that we do not need to specify the types of our variables, including the types contained within an array. If we allow our array to contain any type of variable, we can change how our census worker records information. Let's assume address 0 remains the same with 5 occupants, but address 1 also provided the names of the 2 residents who live there. Instead of recording the occupants as a number, 2, we could record their names in a string. So Main Street address number 1 is occupied by Jordan and Ashley Smith. House number 2 was unoccupied, which we could represent as a 0. But we might also consider recording it as a boolean instead, and give it a value of false to mean that the house is under construction and can't possibly have occupants. At number 3, nobody was home, but there are definitely people living there. We just don't know how many. We could also store this value as a boolean and give it a value of true. At number 4, it really seems like nobody lives there. We may want to mark it as 0 occupants. At address number 5, since there isn't even a house there, we might actually consider using null as the value, since null represents the absence of any value. We can use the keyword null to assign this to the array at address 5. Now our printed array looks quite different, containing variables of all different types instead of just integers. And we can discern more information from it. Arrays can even contain other arrays as their contents. so let's change our list of names from a single string to an array of strings. We can create this array at the same time it is being assigned using square brackets, then populating it with a comma-separated list of strings as its contents. So if we wanted to know how many people are living at address 1 on Main Street, we could print that out as mainstreet1.size. In the next lesson, we'll learn more uses of arrays to create more dynamic data collections. I'll see you in the next lesson.